All right. So we're doing okay. We're about a minute past the official start time, and folks are still streaming in on Zoom. But I think in the interest of getting the show on the road, I'm going to go ahead and start with the introductions. That'll give the folks who are coming in another couple of minutes to get everything settled. It's my real pleasure today to be the moderator of this iteration of the COPSS-NISS Leadership webinar. This one in particular is focused on leadership in translational statistical research. And I am absolutely pleased to be able to introduce both Dr. Sherri Rose and Dr. Taki Shinohara. Sherri Rose is a professor of health policy and the co-director of Health Policy Data Science Lab at Stanford. She has been working in developing and integrating innovative statistical machine learning approaches to improve human health and health equity. In the interest of thinking about things that are sort of interdisciplinary and translational statistics, I want to emphasize that she has published in journals like Biometrics and the Journal of the American Statistical Association, but also in the Journal of Health Economics, Health Affairs, and the New England Journal of Medicine. She's won numerous awards. She's a fellow of the ASA. She has won a NIH Director's Pioneer Award and New Innovator Award, the Gertrude M. Cox Award, and the Mortimer Spiegelman Award. And her work has been featured in the New York Times, USA Today, and the Boston Globe. Dr. Taki Shinohara is professor of biostatistics and epidemiology and the director of the Penn Statistics and Imaging Visualization Center, or PENSIV, at the University of Pennsylvania Perelman School of Medicine. He's also the director of the graduate group in epidemiology. He has a lot of other titles that include things like senior scholar, affiliated faculty, full member, senior fellow around different centers and institutes in the University of Pennsylvania School of Medicine, which I think reflects his real interdisciplinary approach to work. His papers have been cited nearly 20,000 times. He's published often in outlets like PNAS, Nature, Science, Neuroimage, and Human Brain Mapping, but also in Biostatistics, Biometrics, and other statistical journals. It's like I say, my real pleasure to have both of you here. Thank you both for joining today. I have a variety of questions that I, hope to ask, but folks who have signed in to listen in, there is a Q&A feature here in Zoom. Please use that to raise questions. I'll keep an eye on what has been brought up and happy to raise those questions as well. The structure that I have for the things that I wanted to ask about is sort of keeping in mind this overarching idea of doing translational statistical research. And so I'm going to start with a few questions that have to do with sort of your early career approaches, think a little bit about the work that you're doing now in mid-career, and then get your thoughts sort of looking ahead. With that in mind, I sort of want to ask you both to think back to when you were sort of starting out. You both did PhDs in biostatistics, but very early established an interest in different substantive areas. Sherri, you in health policy and ethical approaches to AI, and Taki in neuroimaging. And so I wonder if you can just talk a little bit about what it was that drew you to those substantive domains. And maybe Sherri, we'll start with you.
Well, thank you, Jeff, for the introduction, and it's wonderful to be here today. I don't know how far back I should go as far as the formative experiences that influenced my interest in health policy, but for the sake of time, I won't go too far back today. The main thing that drove my interest scientifically was interesting problems that needed solving. I saw that there were fewer statisticians working in the area of health policy. There were major challenges where a different way of thinking about the problems, the way that we think about problems as statisticians. I saw a lot of potential for, being able to have an impact. And then the kind of non-scientific, I had a lot of personal interests in solving major challenges in health policy, including around, healthcare access for individuals who are minoritized in the healthcare system, access for all sorts of different problems we have in healthcare, and the way that we could in general be doing a better job in health policy. And my own personal experiences growing up low income really influenced that as well.
Thanks very much for the introduction, Jeff, and for the opportunity to be here. I'm honored and very much looking forward to the discussion. To tell you how I got into neuroimaging, well, I think there's a sort of a theme that probably will occur in a lot of my responses to some of these questions, which is, for me, it's all about the people. It's always been about the people. I had an incredible collaborator who spoke to me about a problem that he was really engaged with and interested in, and it sort of went from there. I have to say that neuroimaging is especially intriguing to me, in part because the data structure just allows you to be able to visualize them, and being able to look at your data in their raw format is just really something that I find thrilling. And so that certainly played in. But I think for me, finding the right collaborators and finding the right network of people to work with is probably what drove me to the area I'm in.
Fantastic. So what did that look like, though, especially in the early stages when you had developed a lot of expertise in public health and biostatistics? Like, how did you go about establishing either that network of collaborators or building the foundation of knowledge that allowed you to be successful as an interdisciplinary researcher in those spaces? Taki, you go first.
Okay, so for me, that finding collaborators was about knocking on doors, finding new people to meet with and talk with, especially early in my career. For example, when I moved to Penn, and meeting other collaborators through those collaborators and developing a network. That was really important. I'd also say that attending scientific conferences beyond the statistical conferences that we usually think about, so important. And through those connections that I was able to very honored to develop, I certainly had new opportunities that arose.
Sherri, I saw you nodding, especially on the going to conferences piece. What else sort of worked for you?
I agree with a lot of what Taki said, including going to things like conferences outside statistics, also seminars. That's where a lot of folks ask me, I don't have any actual training in economics, but I started going to a lot of econ seminars and having conversations with people when I saw things that were interesting, or meeting with the author who presented, or colleagues in my department. I was in and still am in an interdisciplinary department that had folks with lots of different types of training, including in econ. I will also add another facet that you will make mistakes with collaborators, and mistakes can be a variety of different things. You could decide that you're not interested in the project. Another big thing for me over my career has been making sure that my collaborators have the same values and have the same way of doing science. And that is something that you do learn a little bit by trial and error. And so I, back when I started my career, and even more so now, having learned from those collaborations that weren't necessarily a fit, I'm really cautious before I start working with someone. I like to get to know them. We talk about shared values, including things like rigor and reproducibility and posting code, and not doing things at the last minute when lots of errors are going to be introduced. And what is their goal in doing the project? If they're chasing a bunch of papers, or their goal is a paper in a particular type of journal rather than solving an actual problem, that's not going to be the right type of collaboration. And so recognizing that it's okay to realize that a collaboration is not a fit, and thinking through having some of those tough conversations, or finishing a project and then not necessarily working with that person or that group again.
Yeah, no, I think that makes a lot of sense, and we're gonna talk more, especially about building collaborations as we go through the day. I guess one of the things that I'm curious about for both of you, it sort of came up, I think, Taki, you touched on it the most directly, about sort of recognizing, like, I'm not sure I have expertise in this area. I'm not sure that I really know this as well. I wonder, was there a point at which in your career you sort of had the opportunity to sit back and be like, oh, I do know what I'm talking about in this, and I actually am an expert. Like, what did that look like for you? And again, I sort of pointed this at Taki, so I'll ask you to go first. But Sherri, yeah, but I want to hear from you next.
I think throughout my career, I've always been, I try to always be humble about what I know and what I don't, and try to learn more. I certainly, in a room of imaging scientists, I probably have the most experience in terms of fundamental statistical background, but I certainly don't have as much experience in the context of MRI acquisition as the physicist in the room, or in clinical care of disease as the psychiatrists or neurologists in a room. So one of the things that I find to be really exciting and rewarding is to just have a seat at that table and to be able to contribute with the background and the knowledge that I have. But I'm not sure that I just think it's important to respect that everyone comes from a different background and contributes, can contribute a lot. And one of the things I've loved about the field of imaging statistics has been the openness and the gratefulness of collaborators in the context of working with statisticians and the respect. It's really been fantastic.
Mm. Good. Anything to add, Sherri?
Yeah, I mean, I echo a lot of those sentiments, and I think, you know, being humble, but also being secure that you have a contribution, that you do bring things to the table, and then harkening back to our conversation about collaborators, you know, being with collaborators who do respect you as a scientist, and you know, because sometimes you can get on teams as a statistician and you're not given the same respect as folks who are coming in with different expertise, and so making sure that yes, you come in and you have a tremendous amount of respect for everyone in the room. They know things that you don't, but they also respect that you know things that they don't as well. And I think, you know, as far as your comment about, you know, at what stage did you have this realization? One of the things that I really relish in my career now is again just being so comfortable with not knowing things and learning every day. That's one of several reasons why I got drawn to the field of statistics, was that it was just continual learning. And so embracing that you don't know things, I think is great. And we should all be more comfortable with that and showing that we don't know things.
So I think it's really interesting. You both sort of talked about being in an interdisciplinary space where you recognize that other people have a lot of expertise that you don't have, but also like recognizing your own background and often like being the very strong quantitative researcher, especially the person with a statistical background. And since we're sort of thinking about leadership in statistics and leadership and today in translational science from a statistics perspective, I wonder if you can sort of talk about how you view your roles as a statistical researcher, what you sort of think of as the things that you need to bring to the table in order to be successful. And maybe we can talk a little bit about methods development as part of that. And Sherri, just to keep it going, I'm going to ask you first.
Sure. So when I think about leadership in statistics, it kind of dovetails nicely to what we were just talking about. There are times when I'm on the team and you know, I'm a collaborating team member, but there's also times where I am leading the team and I am both a subject matter expert and a statistical expert. And oftentimes in collaboration with a student or a postdoc, we're developing methodology together tailored to a particular applied problem. And so, you know, balancing those types of skills, we don't learn in most of our degree programs how to manage a team, how to run a team, how to create an inclusive, supportive culture for trainees and staff. These are not things that I was taught. And so I think for those of you who are early career, you know, engaging with learning how to build teams and how to lead teams, and then also, again, how to be a gracious member of a scientific team when you're not the leader, are super important skills.
That was such a great answer. I totally forgot the question.
I'll paraphrase. The question is like, you're walking into a translational team science environment and you're the statistical expert. Like, how do you conceptualize your role as the statistical expert in that space? What are the things you try to accomplish?
Thanks. So for me, when I walk into a setting like that, oftentimes the first thing my first order of business is to understand and learn about the problem under study to better be able to judge how I can contribute. I don't always see myself as being responsible for policing the science that goes on in the context of, for example, a consortium, but nonetheless, I hope that I can contribute to improvements in scientific rigor. And then a big part of what I'm doing is trying to learn and listen and identify opportunities in terms of new potential projects for statistical innovation, or for the translation of statistical techniques from other fields into the field, at hand.
So on the subject of statistical innovation in particular, Taki, you had just sort of raised this. When you identify a new area where you sort of think like this is it, this is going to be great, I'm going to come up with some new statistical methods, this is what I'm like really excited about. Do you ever, like, thinking about communication of that specifically back to the domain experts, do you ever run into issues with that part of communication? And what does it look like trying to convince either a health policy expert or a policymaker, or Taki for you, somebody who has real clinical expertise, when you're coming in and saying like, here's the newest, coolest statistical method you've ever seen? How do you convince them to buy into that?
I can actually go first. I think that in some ways that's really a moment where I learn a lot about the collaborator that I'm talking to, or the team that I'm a part of. Usually what happens is that everyone's very excited to be able to learn about the idea that we have and the opportunity that we can undertake together. It's very unusual, but I certainly have had certain circumstances where I pitched something and it didn't go great, and nonetheless I thought it was something I wanted to pursue. And to be totally honest, my usual answer there is to say, hey, I don't hear a lot of others who really want to quarterback this. Is it cool if I write a grant about it? And nobody's ever concerned about that.
Sherri, anything to add?
Yes. So one of the aspects that I'll highlight is being really straightforward about where in the pipeline the work is at. So oftentimes when working in a policy sphere, when I'm doing methods work, it is sometimes 5 or 10 steps removed from being able to make a policy recommendation. So oftentimes that first paper, that second project, even that third project, you're still working out how that methodology can really potentially be useful in practice. And this is, again, where we want to be incredibly careful before we would make a policy recommendation, that just because something's very interesting statistically, that it could actually lead to an improvement in whatever problem we're trying to solve. And so that's one of the reasons why I end up having papers kind of across a variety of different types of journals, is having that clarity and not overselling what you're doing, which is one of my many frustrations with statistical, CS, AI, all of the literature just overselling. I solved this problem, I wrote one paper on it, when it's completely removed from how we would actually do this in practice. And then sometimes this means when I'm working on something that's incredibly timely, a lot of the statistical innovation has to come out of the paper in order to publish it in a journal that is going to reach policymakers. And so sometimes it's either buried in an appendix, it actually fully comes out of the paper. It's something we might publish later, but there's a journal, Health Affairs, where we want policymakers to read this and potentially have an immediate impact. And we've been in situations like that. And it was much more important to get the part of the work that could have an immediate policy impact out than to focus on getting that interesting, nerdy statistical content in the paper. I'll also say doing interdisciplinary work, and I've heard this from many people, I've had this experience as well, it can be really challenging publishing your papers because it's often somewhere in the middle of journals. The stats journals often say this seems more applied. The applied journals say, oh, this is too technical. And so a lot of my papers, the conversations I have with students, I say, oh, this is a little bit of a weird paper, that I have to catch myself and say, I guess a lot of my papers are a little bit weird. But that's what happens when you're working in a paradigm that's actually interdisciplinary and not this false, oh, I've solved an applied problem without really knowing anything about it.
Yeah, no, actually, that I think is a really good point. It was the sort of the next thing that I wanted to think about in doing like translational statistical research and innovative methods development in this space, is that, like you say, Sherri, one challenge is both like getting people on board, but also having a venue where you can really present sort of your new statistical ideas. But then there's sort of like a flip side of wanting to make sure that something that is motivated by a very concrete problem is still recognized for the statistical innovation. And so you talked about, a difficulty at times in publishing work that is motivated by applications. Have you found any solutions to that? Do you have any strategies for that? What are the kinds of things that you try to do to get your statistical work recognized?
Is this back to me?
That's back to you, yeah.
Okay. So I think one of the things, if we're being super honest about leadership, one of the skills that I still lack is, handling the reviews as efficiently and rationally as I could. It is very frustrating to continue to send your work out. And, there was one paper that, again, was a weird paper that I think we went to 12 different journals. And that is a really inefficient part of the process. But I will say that in general, even though I've had frustrating journal rejections, and of course there could be people at this event who had rejections from me when I was a co-editor-in-chief of Biostatistics, there's subjectivity about how we decide which papers to publish. And so even though I've had frustrations, I ultimately have been able to place work that I thought was really, that was valuable. And again, that's trying to focus on projects that are not least publishable units. When you're churning out tons of tiny little papers, it can, it just adds to the problem. And so, you do have to slowly, for me, develop this process of, okay, this type of journal wasn't interested. And sometimes that pivot can be, I recently had a paper where, we thought that the clinical innovation was really going to be relevant and potentially exciting to clinical journals. We got 2 desk rejections. And so we pivoted and sent it to a more technical outlet, and they took it. And so it can even be not just going through, okay, which is the next statistics journal I'm going to go to. It's let me pivot and go to, let's change the paper slightly, because we barely changed that paper at all. And so recognizing that, this one is striking out with either stats journals, or this one's striking out with the applied journals, and let's go in the other direction.
You'd say in the field of neuroimaging, one of the things that I'm very grateful for is that there are a good number of interdisciplinary journals. And I think previously these journals published a lot of different papers in everything from clinical psychology to MRI physics. And so we found that many of those journals are actually also super excited to publish methods papers and translational methods papers. And so it's been really nice to find journals that you might not think about publishing in, but that have focused on transdisciplinary work that haven't included statistics, being open to including statistical work as well.
Awesome, thank you. So like I said at the outset, the way I was sort of conceptualizing this was sort of talking a bit about some early career stuff and getting established in statistical methods and in domain science, and then sort of transitioning more towards some mid-career kinds of things. And so I want to be sort of explicit about that. And I'm wondering if you can sort of think back over, what that sort of transition phase looked like from being like a junior faculty member, somebody getting started, trying to make a name for yourself in both in statistics and in health policy and neuroimaging, respectively, to now sort of leading teams and taking on different scales of challenges and working on different kinds of projects. And I guess I very broadly want to ask you to reflect on what kind of professional growth happened in that time period. What were the strategies, if you had them, that helped you be successful in sort of managing a transition? Did you recognize you were sort of making a transition at the time, and so on? So again, Sherri, maybe I'll start with you.
I'll be really transparent here that it was challenging for me in the beginning, because being interdisciplinary, I felt like I had to do 100% of the work of a statistics faculty member and 100% of the work of a health policy faculty member, which meant that I always felt like I was failing at my job, because you can't do 200% of the work. And so that really, again, brought me back to needing to focus on my values and living my values. I wanted to do work that was both. I didn't want to be one or the other. And really having to filter out messages that I was getting that only one of these types of research careers was valuable or was important. And so that was personal growth that I had to go through, and was also something that now that I'm further along in my career, I really try to contribute to having a positive environment that, you know, in the statistics profession, we should embrace this kind of work. We are trained as statisticians to do incredibly deep, meaningful applied work, and also, you know, focusing on methodology. And you can do both, and you can be both, and we should have a space to be both.
Yeah, thanks for sharing that. Taki?
For me, I think the transition from, you know, early career to mid-career has been pretty sort of smooth and also gradual. And so now this is sort of been an interesting question for me to reflect on, to think about how things have changed. I would say that when I was earlier in career, I was very focused on having an impact in the context of the work and leadership roles that I could take on. For example, in consortia, being on steering committees, those kinds of opportunities. And I remember to some extent sort of fighting to have a seat at the table. And now I find myself trying to prioritize, and also trying to offer opportunities that I have to more junior folks, and grow the prominence of our field of statistics and biostatistics, and in the other scientific areas that I work in. So maybe that's been something that I've noticed, but it's been a great ride.
Yeah. I guess like even to sort of like try to distill things down a little bit more, I wonder if you can sort of, as you're looking back on like your own professional growth, are there either things that you wish you had done differently, or advice that you would give to more junior people at this point? And again, just sort of curious what your take on that is.
Things I would have done differently, that's a tough one. I feel like it's very, you know, it's easy to look back and think I made the wrong mistake. I, you know, could have hired an additional postdoc and done something more, or entered an area, built a collaboration in something that really grew very quickly. But I suppose it's always a challenge to think about how things could have been. But it's definitely important when you're growing as a junior scientist. When I was growing as a junior scientist, I should say, to realize that decisions could be impactful. Taking your graduate student meant a commitment of thousands of hours towards ensuring the success of this person, both during the program and of course afterwards as well. So yeah, so it's did feel like a lot of difficult decisions, but many good outcomes.
Yeah, I would add, it's when you think back about doing things differently, I mentioned at the beginning of this things that I refer to as mistakes, but in some ways you have to make mistakes to learn the lesson that came with it. And so there's all sorts of things that I've learned that I wouldn't do again, but I needed those to happen, but not to keep repeating myself and this, but really something that I would love to not have done again if I could go back is internalizing other people's values, because depending on the environment where you get your training, you just get inundated with certain things that a lot of them are really artificial. A lot of them can lead you down a path that for me would not have been fulfilling for my life. And it was really helpful to have other people in my life that helped me remember what I actually valued, and that I didn't need to value this thing that other people told me to. And so that's something that I wish I could go back and tell myself, care less about what other people are saying and thinking of you or saying to you about what matters. It's helpful to just, it's helpful to hear from people, to learn about, okay, this is where the profession is at. But for me, I just internalized it way too much. And I'm really glad that I ultimately did make decisions, including which jobs I took, including, where I published my work or which projects I worked on, when I was getting a lot of forceful pushback sometimes from people who told me that that was really bad for my career or that I shouldn't do that. And yes, I wish that I had not just spent so much energy on those things that ultimately were not helpful or productive for me.
Thanks very much for that thoughtful answer. One of the other things that happens as you sort of go from early career to mid-career is that, yeah, there's a lot more stuff that you get asked to sort of participate in and help out with. And there was a good question in the chat that asks about sort of balancing the work that you want to do and also leadership and participation in statistical societies. And I know you've both been active in working on advancing the profession. And so the question in the chat is, how do you balance your time? How do you decide what to participate in? How do you split your time between leadership and research and participation in societies? Sherri.
So this is where I found trying things out early career was really helpful. I've often had many opinions about how we could potentially improve things in our profession. And so that started early when I was a postdoc, when I organized an informal group of early career statisticians where we had recommendations about the joint statistical meetings. And we sent that to Marie Davidian, who was the ASA president at the time. And that's rolled into, she recommended me for the JSM, committee on meetings, and then that rolled into roles with the biometrics section, where I had many different roles, and then ultimately was the chair. And then I've had other different types of roles in statistical societies, and also participating in, health policy and health econ groups as well, and figuring out which types of those activities I enjoyed and I felt like was having the kind of impact I wanted to have, or the type of role in the community, because there are things that we often do that maybe are less exciting but need to happen, and we enjoy doing it because it's a community good. And so for me, experimenting with the different types of activities, and then at a certain point recognizing, okay, this kind of role, either I have finite time, I can't do this kind of role, but I do enjoy this type of role, or, the number of roles. I enjoy all of these, but each year I can only commit to one thing, and then I have to say no to them all. And regarding the question, I actually had to make a list for myself of things I wasn't allowed to say yes to anymore, because it's always, oh, this is just an hour of your time, or this is it'll only be this amount of time, and it's always more. So as far as kind of learning from and calibrating based on what you've already experienced, that's what I've done a lot of, and really focusing on, these are the types of activities that I want to contribute to my time where I can uniquely make a difference, versus somebody needs to do this, but it doesn't necessarily have to be me.
Totally agree with everything that Sherri said. One other thing I wanted to add is that sometimes I found myself becoming a little bit overcommitted, and in some ways, I especially as a more junior person, I think that can be really detrimental, because part of the reason why we participate in societies is to be able to contribute and improve the society and improve the opportunities of the members. But then also another reason is to build a brand and meet people and build a network. And overcommitting can be really dangerous, because the last thing you want to do is cause a detriment to an activity or program that the society is running. And you certainly also don't want to come across as not being able to perform the duties you agreed to. So choosing those roles and dedicating yourself to those roles and as they evolve thoughtfully is really important. And it is difficult to say no, but it's important.
So thanks also for posting that in the Q&A. If there are other questions, please do add those. If we have time, I'm going to come back to comments that we've had on sort of collaborators, but there was another question that I had that sort of related to another thing that has just come up. And so I guess I want to like take a step back and ask you both to sort of think big picture, future of statistics, these kinds of things. And I think right now I don't know that it's unique to right now, that there has been a lot of like real concern about AI taking over and making statistics obsolete, but 10 years ago, data science was going to take over and make statistics obsolete. But so I guess for the two of you, where you said is both, you know, researchers in translational statistics, but also domain experts, I wonder if you can sort of think a little bit about those sort of alarmist takes on the future of our profession, and sort of where you think whether there are real threats, whether you see it more as opportunities, whether you sort of, what do you sort of view as the next step in biostatistics and translational statistical research? Taki, you have to go first this time.
Okay, great. So yeah, I really do see this as see the increasing import of AI as an incredible opportunity for biostatistics. The values that we have, the questions that we have in the context of statistical research are, I think, really universal and will persist. And the availability of new tools that can be useful to try to help answer the questions that we and our collaborating scientists have, it's really fantastic. So engaging, learning more, trying to figure out where these tools can be useful towards our goals, I think are really fantastic opportunities. And we should be excited about this.
So I also view this as an opportunity. As statisticians, the training we get it just has an incredible depth to it that you don't see in a lot of the kind of quick, short paper, fast, ad hoc AI hype type of work. And I think as statisticians, because we bring this grounded perspective to it, that we can help, same way as 10 years back when people were overhyping, data science was going to do this and that. And now that we have these large data sets, that eliminates any problems, just more data means that there's no problems in trying to answer research questions. So the fact that we have, in my view, a proliferation of really bad AI work now, and just even more added hype that has infiltrated the public consciousness, that it is an opportunity to do better work and to do more grounded work and to be a bulwark against some of that. And also, where you have opportunities as a statistician to kind of push down that hype and bring people down. And that's often a role that I play, even just in regular conversations around campus, when people see a headline or they read an article, and then I can help give them more context and in some cases calm them down.
Thanks both for that. I mean, I'm probably not going to surprise you by saying that I agree. Taki, you mentioned a little bit about sort of adopting some of these tools, and Sherri, you did as well, about sort of incorporating the best emerging technologies into the work that we do as statisticians. And I guess I just sort of wonder if you can comment on that a little bit more broadly. Are there like specific kinds of technologies that you think are particularly relevant now? Are there things that you think in biostatistics and statistical research we should sort of really be eager early adopters of?
I can say, there are a few examples, but I think the usefulness of deep learning in the context of, for example, dimension reduction is really fascinating, and I think we can learn a lot about structure of data in flexible ways that can help us to be able to model associations of interest in the context of prediction models for outcomes. I think there are also a lot of opportunities, but challenges as well.
Mm.
And being able to interpret and understand the behavior of prediction models can be really important. In the context of neuroimaging, of imaging science in general, a lot of these deep learning tools have been adapted to or developed for the problem of segmentation, for example, finding something in an image that you're interested in. For those kinds of problems, it's great to be able to use a quick and flexible tool in part, well, I should say in great part, because at the end of the process, you get a map and you can take a look at it or have a radiologist take a look at it and tell you, yep, did well or it didn't. But in other problems where it's more difficult to understand what the implications are in the context of studying disease, that's a tougher challenge. So I think it really depends on the problem, the question, but there are a lot of opportunities. Yeah.
Great.
One thing I found over my career so far is that, whatever the new flexible tool is, that there can be use cases for it. I work in, the applications that I work in, we often using either ensembles, either for prediction or within, causal effect estimators. And again, it comes down to back to those first principles of, is your estimator something that you can write down that's grounded and has both, theoretical, properties, asymptotic properties, but also, finite sample properties. Can you write down your target parameter non-parametrically? Can you really explain what it is you're doing with these more flexible tools? Because, way back when I was in grad school, random forest was the one that's like, oh, this can do everything, it can do everything. And it, it attenuated, included in your ensemble, or potentially use it for a prediction question or to estimate a nuisance parameter for an effect parameter. But, and then it's neural networks. And then, now we have all these other tools. In my work, there are often use cases. In many cases, it doesn't perform better than something that is more easily communicated to a policymaker. And so that's a balancing act that I play in my work, is both developing and using more novel tools, but also recognizing that sometimes the simpler tool is going to be something we can actually deploy. And so in some of my work, it's not necessarily, are we using the fanciest deep learning? It's, deriving more efficient and effective loss functions that build in aspects of fairness, which is not about a flashy tool. It's really about, again, thinking, what is the outcome that we want for this problem and to serve this population. So I do think that there are cases where these can be useful for health policy, but that, again, the hype around it is really overstated.
Great. Thanks for that. So a lot of the questions that I had are sort of like thinking about where we are in statistics now and where we are looking forward. And there's a question in the chat window that I think makes this even a little bit more concrete, which is like, if I'm studying right now, what should I be focused on? If I'm studying right now, what should I do to prepare for a career as a data scientist? Which could be, yeah, go to class and learn about estimators, but it could be like stay up to date on the most current stuff in AI. And so I'm curious what advice you have for students now who are preparing for a career in applied statistics and data science. Taki, you are director of the GGEB. You have to deal with this all the time. You go first.
Thanks. So I think for me, I'm going to go back to the people here. I would say in the context of my training and then in the context of my growth over the past 12 years, I feel like finding collaborators and mentors has been incredibly important to be able to learn about science, both statistical science, but especially the sort of translational science areas that I've worked in. That's been really incredibly important. So I would say for a student looking to develop a program in an area of translational science, find great friends that you are excited to work with on problems that are impactful and that you agree are going to make a difference.
One of the things that I would add is that in my undergraduate experience, one of the things that was challenging was I would learn about a particular type of statistical method in a class, and then in another class, I'd learn another one, and then another one, and I didn't know when to use what. And it's not like I wanted a table that said, use this then. I was really interested in having a framework for taking actual research questions and translating them into a statistical estimation problem. And that is something that I definitely got in my graduate school career. And I think if that is something that resonates with you, make sure you don't leave graduate school without it. If I were to say whether it's an applied problem or a technical problem, if you don't know how to write that down, and that includes things like I already mentioned, like what's your parameter of interest, write that down concretely, which is something that a lot of people can't do. So when the comment you brought up, stay up on the AI literature, it's impossible. Or as a statistician, I don't like to say things are possible. It would be very challenging to stay up on there's hundreds, thousands of papers coming out every day. And as a graduate student, I know I wouldn't have been able to filter out what's actually important work and what's actually a great contribution. And so, yes, it's important to learn about different types of estimators, but the first principles of statistics, those things are going to help you learn what the new tools will be in 5 years, or to help develop them yourself. And so that's one of the most important things that I got out of my technical training in graduate school, was really grounding my education in those first principles.
Yeah, and I mean, it seems like that's exactly the kind of thing that you would need in order to adapt as new technologies become available, as new techniques become available, to sort of revisit what is important in terms of answering a new scientific question. Taki, I'm actually going to come back to you because you mentioned this very specifically. There's another question in the chat about mentorship and what role mentorship has played in your career. How have you gone about finding good mentors? What are the ways that you've cultivated those relationships? How do you leverage mentors in trying to sort of figure out what to do next in challenging situations? So like I say, Sherri, I think we probably will come to you with the same question afterwards, because I'm sure you have experience in this as well. But Taki mentioned it, and so it's coming to him first.
Yeah, I have been incredibly lucky to have wonderful mentors, thoughtful, dedicated, advocates and mentors over my time as an undergraduate student, graduate student, and then certainly as junior faculty. And I found my mentors in many ways. Some have been assigned to me by my division, and some have, and I've had to have more formal meetings and discussions with, and others I've had I found because they're in an office next to me, or because they're a collaborator, or because they are in the same consortium that I'm a part of, and we've just gotten along. And they've certainly had a huge impact on me, both personally and professionally. And it's so incredibly important it's been incredibly important to me to have someone to bounce ideas off of, to tell me when I'm being stubborn about something, or when there's something that I should stand up for, or when there's a project or a paper or a grant that it's time to give up on and move on to the next thing. So yeah, I'm very grateful, and I would say openness to finding mentors is really very, very helpful.
Yeah, I would add that I was really intentional about having I wasn't so focused on thinking of it as mentoring, but having a group of just peer colleagues across universities was something that I tried to create. And I realized along the way that we were peer mentors to each other, because oftentimes we were either going through things at the same time, or one of us had just been through it, because and then it was the next person's turn. It's like, oh, how did you deal with hiring your first staff member, or what did you do in this case, and really learning from each other's experiences. So I want to make sure to highlight that aspect, that mentors don't just have to be many years senior to you. But of course, I've also benefited greatly from senior leaders in the field. You know, when I was a PhD student, my advisor, Mark Vanderland, was just an incredible mentor. And all the things that I've talked about as far as things I wanted to get out of grad school, I learned so many of them from him. And he was a very giving, dedicated advisor to students. And then, you know, throughout my career, you know, whether it's an advisor that you're assigned to, you start talking to different people at conferences or within your department, but having a variety of perspectives is really helpful. As I talked about before, you will get a variety of advice, and it's helpful to hear different things from different people, because you'll realize, oh, I was told I have to do this, or I should do this, and then hearing from someone else will say, oh no, you don't have to do that. And then you can filter for yourself whether you're going to do that thing. And I will also say I've just benefited greatly from mentors who are also sponsors, who have gone out of their way to, you know, whether it's, you know, nominating me for opportunities, formal and informal. And the role of sponsors is really important, people who are going to invest in you, and then paying that forward, you know, throughout your career as well, that mentoring and then sponsoring other people and investing the time to do that.
Great. So these are really insightful answers to a lot of different questions. And I think there are a lot of things that we could continue talking about for hours and hours on end, but I'm aware of like the time constraints that we have and that we're approaching the end of the panel. And so I think I just wanted to, as a last question, want to ask you both what you're working on now that you're most excited about, an opportunity for a little bit of a shameless plug, or a little bit of bragging, or just something that you think is just really neat and exciting, that you're excited about working on now or want to work on next. Taki, you have to go first.
I would choose. I am so excited about so many things. I guess what I'll be working on for the next couple of months is a grant resubmission on a scientific problem that considers statistical properties of tools that were not built in the context of a principled statistical framework, but nonetheless have properties that that we want to be able to understand in the context of pre-processing of images. And I'm really excited about that. I'm also really excited about. I'm too excited about too many things. I'm gonna stop.
I'll mention that I have a number of projects that are both about algorithms and also not. So in a lot of my work, we are developing new statistical learning algorithms. But in some of this work, we're actually studying algorithms that have been deployed and whether they work or not. And so, and then potentially advocating that algorithmic solutions are not necessarily the answer to this policy problem. So this has come up many times in my work, including an area that I work in, planned payment risk adjustment. Even though we're developing, you know, novel loss functions and novel estimation methods, it's not always the case that every answer is a change to the formula, but might need to be a legal solution or some other solution outside a loss function. And this has come up in recent work with a student, Marika Cusick here at Stanford, and our collaborators at Stanford Healthcare, where we studied a change to the EGFR equation where they removed race adjustment back in December of 2021. And so we studied the real impact of removing race adjustment from that formula after 2 years, and we found that there was no change. And this was not necessarily something that was surprising to a lot of nephrologists and people who work in chronic kidney disease care. So even though this race adjustment was not clinically supported and is something that reinforces structural racism, but algorithmic solutions alone cannot combat health inequities. And so we highlight in this paper that was just accepted at a computer science conference, CHIL, and Marika will be presenting it in June, we highlight that we have to also focus energy on these structural issues and these social determinants of health and access to care and people's lack of access to transportation and all of these other issues that have a much greater role on having actual better health outcomes than necessarily focusing all of the energy on potential formula changes. So there's some that we should definitely make, but a second half of this project was that we were going to propose another change to the formula if this one didn't necessarily yield the types of outcomes that we wanted. And we decided to pivot because we thought this energy would be better spent pursuing other avenues that are not necessarily algorithmic solutions, because that's not necessarily where we're going to see the greatest impact.
That is, I mean, both very exciting. Thank you both. Like I say, we're basically at the end of the hour. So I want to take this opportunity again to thank you, Sherri and Taki, for all of the work that you've done over many years, and also taking time this afternoon to share your insights with this venue. Also thank the folks at COPSS-NISS for all of the work that goes into organizing not just this webinar, but the enlightening series that has taken place over the last year or more. Thanks everybody for taking some time to listen in this afternoon, and have a good rest of your day.